ladies and gentlemen, we are looking at the string problem. Suppose you have 1 yard of yarn, fold it in half and cut at the fold. You are left with 2 pieces of yarn. Record the length of those pieces in the table below. Continue repeating this process to fill out the table below. So first we're going to make a prediction about the length of the string in the fourth stage. I'm going to believe that it is 1/8 as big, and we'll see if I'm right. Now we're going to fill out the table. All right, so my guess is 1/8. So we are going to look at filling out the table to figure out what it is each time. So excuse me, my computer. All right, so at stage 0, we have 1 piece. So it's 1 yard long. The length of it is 1 full yard. So at stage 1, we've taken the piece and cut it in half. So we have 2 pieces, and it's half as long. Stage 2, we've taken those 2 pieces and cut each one in half, and we all of a sudden have 4 pieces, which means they are 1/4 as big as my original piece. Then we are looking at stage 3. We took 4 pieces, we cut each piece in half, and all of a sudden we have 8 pieces. They are now 1/8 as big. Those 8 pieces again, cut each one in half. We have 16 pieces. They are 1/16 as big as my original piece. Fifth stage, we have 32 pieces, and we are 1/32 as big. Does the length of the yarn change with each cut? How does it? It is cut in half each time. It is half as big as the previous. Okay. So then we are looking at how long was the string at the fourth stage. We were wrong. It was 1/16, and no, we weren't. We forgot about the 0 stage was the issue. If we're wanting to write a function of the yarn in this stage, now stage X means no matter what I plug in for the stage, I would come out with the right answer, and it is doubling each time, so we raise it y equals 2 to the x. Any stage we plug in, if we plug in 4, we would get 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. The length is y equals 1/2. It's getting cut in half each time. If we plug in 4, we would get 1/2 times 1/2 times 1/2 times 1/2, which is 1/16. Okay, use your function to predict the number of pieces at the yarn at stage 10. So if we take the number of pieces and we take it to the 10th stage, we get 1,024. If we want to figure out how long those pieces are, we take y equals 1/2 to the 10th, and we get 1/1024. It's 1/1024th as big as my original piece was at the 10th stage. Okay, so we're going to graph our function. We know that the biggest number is 32, so we're going to go up each one by 4, because we're going to round up to 40 and then divide by 10. So to figure out my scale, again, I rounded up to 40 because my biggest number is 32. I divided by 10, and I found that my scale will go up by 4s. So I have 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. And my stages go 0, 1, 2, 3, 4, 5. So first I am going to graph how many pieces I have. At 0 I have 1. At 1 I have 2. At 2 I have 4. At 3 I have 8. At 4th stage I have 16. And at the 5th stage I have 32. So we can see my graph there. Now I'm going to graph how big the pieces are. It starts off at 1, and then it's 1/2, and then it's 1/4, and then it's 1/8, 1/16, and 1/32. So we can see the difference with the length versus the number of pieces. Finally, we're going to compare these graphs. Both graphs, or both functions we'll call them, cross the y-axis at 1. Okay? The first first function, the y equals 2 to the x function, grows as the stages increase. The y equals 1/2 to the x function decreases as the stages increase. Okay, so the big thing that we've noticed is if we're looking at our graph, one is exponential growth, the number of stages. One is exponential decay, because it starts big, and the blue one starts big and goes down over time. We also need to notice that no matter how much it gets cut in half each time, it never reaches 0. If we cut, 32nd in half, we get 1/64th. Cut 1/64th in half, we get 1/28th, and so on. And it can be cut in half of many, 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 many times, but never reach 0. We also know, again, green one, exponential growth goes up over time, where exponential decay starts high and gets lower over time.